Sorry guys, there was some transformer blast nearby, so the, the internet was shut down here. Okay, so coming back to the same, so as we were talking that we have the cities data frame, and so I just want that I know what all cities that I need to filter out. I just need to see population of those cities with for which I know the name, right? So what I can do, I can rather than applying the, the filter on population, okay, I can apply the filter on cities names, and I have a list of cities. Now I can apply it saying okay, cities, name dot is in, and bracket, and then I can provide the list of cities. Okay, now the moment I filter it, it gives me that uh, fine. Okay, so now what happens is that my thought process went a little ahead, and I was thinking, okay, why can't we, or I would say, let us step back from this and say, I just might write the wrong spelling, so, or I might have a list of cities. I know they have similar substrings, so why can't I use that substring to kind of filter it out? So, and for that, yes, we have another option here which says string dot contains. It's another functionality. So city's name dot string. So basically stringify this city's name, not, and this string dot has a dot contains function where you can supply your substring. Now this substring is case sensitive, right? So the moment I filter it out, it provides me this. Think of it, it is case sensitive. So if I do SAN, it is not returning any. So better be careful, or do apply some more dot lower, string dot lower. Okay, now think of it. Let's say I do dot lower. Okay, and I think so dot lower. Let us try. I think it will be, it is a function. Okay, sorry, then it is this. Now I think so should contain. Okay. Oh, yeah. So, so in any case, so I don't need to now, write SAN or so. I just have to provide my regex in lowercase, right? It always will look for, it will always, whatever will be in here, whether it is in uppercase or lowercase, it will first lower it down, then stringify it, and then it will check for this condition. Okay, and so how it works. Okay, and then we talk about filter conditions, and just a minute. Okay, so now is about the filter condition. So by the way, Pandas also has this filter function where you say like, okay, you can say that, okay, let me do this, okay, let me name, and then okay, okay, Well, that's something that we have to check. I think I think how it would work is, mm, sorry, uh, filter out what columns that you want to. Now you just have one column here. So I told it that okay, bring all the columns which contains name. Okay, so it will kind of bring all the columns with the word name, right? So and it has brought. So think of it here. It is not much usable, but I'll come to that as well. I think, yeah. So I'll have something that ahead after this. In the meanwhile, now uh, now what I want to do, I want that okay, bring all the cities or only those cities where the name starts with BIE. Okay. Now here I use the lambda functions to which with an apply function. So lambda functions here, as you can see, you can define it like this. Okay. Inside dot apply. So what dot apply does is, so basically, so this is a series. This is a series, right? The single column is filtered out. This data frame filtered out with one name, with one column becomes series, and you can dot apply. And what it does, it takes row by row. Think of it. It takes each row. It's more like a X is more like an index, and then you say that's because it's a series. Now it just takes exactly the column itself. So it applies lambda x, which is the value, which is that row, uh, and row dot starts with, which is name dot starts with BIE. So it will filter out cities where it starts with Beijing. Okay, there is some issue here. Sorry, I applied not. So I applied the other condition. So if I say I don't want cities with this BIA condition, I applied not. Right? As you can see, it's these. I'm only there are lot more functionalities that are available in Pandas, but I'm just sharing which are kind of used on a day-to-day basis, which generally comes in handy on a day basis. So it I see at the end of the day, at the end of the session, this notebook will be a kind of reference point for you to when you are working in your office and you want to, you are working on Pandas and you suddenly think that okay, you just want to validate some of your concepts, and so this will come in handy. Okay, now I was still left with one question that okay, uh, let's say, let's go back to this data frame. Okay, now this data frames, there are a lot of columns, and you can think of, there will be situations in your work real life scenario where the data set that you have contains 300 columns, and you want to only filter out those columns with a certain word, because it's simply not possible to scan 300 columns like this, right? Talk about 300, you just, it's always difficult to even scan these many number of columns which go beyond the screen, right? So here in this scenario, what you can do, use this column data frame name dot filter regex. So in the earlier one here we used particular column name, but here you can just give it okay, give me all the columns which contains room as the substring, and don't forget to provide dot column comma x is equal to 1. Okay, and then dot head. So basically I've done dot head, but I mean if you remove this, then it will give me all the data, and so all the rows are coming here. Only thing is that only the columns with a certain you know certain name of substrings are coming here, right? So that's what we wanted. Now, another thing. Now, the filtering that we have done, now what we want to do, let's use filtering conditions to update certain columns. So now there will be a need where you will say that, okay, you want to just ensure that all the, let's say, usually it happens in machine learning. Let's say, I have target column which is continuous, and somehow I feel that I need to kind of build labels out of it. I want to make it as a classification problem rather than a my target variable being a continuous. I want to convert it into labels of classification problem. Now, what I can do in this case is that let's say I have a target variable as median prices of a house. So, and I can probably bucket it into three labels where I want to, with the help of data set, I can classify, poor, middle class, and rich, right? So I might say that, okay, below a certain value of a house, only poor lives. Okay, between a particular range, only middle, live, and above a certain range, only rich are the ones who live. So these are the houses of rich people. So what I can do in that scenario, as you can see here, here we have mentioned here is that, okay, take all the cities names which contains san as a keyword, and update population to 100. Okay, update population to 100. Now we remember that there was no city with 100 value. So now what it will do, all the cities names which contain San Francisco and San Jose, update the population to 100. Let's see. And let's see. See, it is updated. And so think of it what I discussed as target variable, and so high, rich, rich, poor, and middle class. So I can put in these labels and get away with it. Very easy, right? No? Okay. So similarly, I can do the same update based on, I can say that, okay, apply, take a new column. Sometimes what happens is that we uh, create a new column, and there we generally don't want to make the new column as empty, and we just want to initialize by default, if no condition applied, to a completely new column with certain value. So here in this scenario, let's say I wanted to create a new column, and I kind of by default there is some metric that which says that, okay, if not updated, then by default please update it to 4. Okay, and so that's where what we are doing here is we are saying that, okay, cities.log and cities.log, then there is a colon. Colon says here, this colon says uh, all the rows. Okay, otherwise you have to specify, like, what row to, let's say, top 100 rows or something like that, right? But here we are taking, let's say, okay, update all rows into the new column. New column is just, I'm giving a name. You can give your own name to this column, just for representation I'm giving it. So here it will go, the column name will go here, equal to 4. Okay, the moment I do this and I see, fine. Okay, now somehow I want that, okay, first two kind of first two rows, this column should be value 10. Okay, let us do that as well. 0 to, let's say, 3, first 3 rows, 0 1 2 3, 0 1 2, so it will update 0 through 1 or and 2. and let's see what is the change that comes here. Now you'll see here it will become, oh sorry, I need to update this further as well, and you will see here it will be 10, 10 and 10, 10, 10, 10. Okay, let us see. Okay. Oh, okay. Sorry about that. So it will update the 4 columns. So basically it is also including the final one. Okay, that I need to check, because generally it should happen that 0, 1, 2. So it should have kind of, might be there is a change, or I have to recall back, but I think that it should not have updated this one. Uh, Maybe it's a latest version change that might have happened, but still I have to check. Okay, anyways, so might be a change in my understanding. Okay, so now sometimes also what happens that I are so many algorithms don't work when the data has nulls or not a number. Okay, so now sometimes I mean usually a lot of time is wasted when we kind of create all the training data and everything, and now the moment I'm very much excited to put my data into algorithms, my algorithm says some errors, and sometimes it literally doesn't tell as well that okay, there is why is that error. And usually this happens because there is some null value which is making a mess around it. Okay, so that's where comes the importance of looking out and checking if there is any null value or not. Okay, now if I check this, there is no null value in this data frame, California underscore housing underscore data. Okay, and so then what I'll do, just to demonstrate, I'll put median underscore income, let's say few of the rows. Let's use the previous .loc, and let me use 0 to post few. Let's say how many, 400. Okay, I'll say that okay, let me induce nulls and nans into this data frame, and let's see, let's check how many nulls are there across columns in this data frame. See, 401, right? So so now as you can see that there are 401 rows where this is null, right? So I need to fix this, right? So I know what I need to fix. So I'll always say, okay, what we can do about it. Let's do some manipulations, and okay, now we have done a lot around these things. Let's check what we can do. Maybe I'll apply some filter which says okay, this and column where was the nulls, median income, right? Median income was null, and so where dot is nan is null, right? Let us check how many are those. So as you can see that there are 401 rows, right, and 9 columns, right? So, and you can see that I'm able to filter out with this, right? So this condition is helping me out, and I can see as well that there's nans, right? So now what I need to, as we did in this example, here, if you remember this one, right? Now, similar to this example, what I can do, I can say where this column is null, okay, put median income to maybe, let's say, a static number, or maybe I might use complete. Yes, first calculate and then let us first validate and calculate it individually. Let me, impute it by, average. Let's say, what is the average? So average of median income so it will give me, it should give me, sorry, I think, okay, I think that will first I have to do group by, and it's not needed, I think, but I can use it like this. But here it will first do, maybe I can directly apply it here. I don't need to worry about this. And then I put it here. Okay. So now, okay, now I have to, oh, okay. Then I have to, what I have to do is, let me change this with a single value for now. This says 3.9, so what I can do 3.9. Okay. Oops. I am doing some mistake here. Oh. Okay. Oh, I forgot. Sorry, guys. And I forgot to take LOCC. Okay. So as you can see, dot .loc, I forgot to write dot .loc, and due to which it was, I cannot push it directly. Okay. And now my rows are updated. Now if I see, let us cross check. Let us cross check and see California healthcare frame. The first rows I should be able to see, that 3.90, right? So I have imputed this. And now I want to just, I might be having some date wise, let's say date 1, date 2, date 3, date 4. We'll take up this in the next lecture on time series data. But for now, think of it that I want to do cumulative sum, row wise. Let's say I want to add these, and further till the end, more like a cumulative sum. And this comes in very handy sometimes, and then, I can use this function. But let's take it next week, or in the next lecture, which might be next to next week. So let's move on to, we are short of time. Let's move on to the apply function, which already we discussed. But let's say I want to identify the difference between total rooms and total bedrooms. I want to apply this function, though I could have done it in multiple ways. But I'm using the lambda function here. I'll show the other way as well. So what I want in this whole if we go back on the data frame, so I want the difference between total rooms and total bedrooms. So basically I want to identify at a particular location what are the other rooms apart from bedrooms, how many number of rooms are there. So I do one thing that, okay, I say for each row dot apply, so basically data frame dot apply for each row lambda x dot total rooms, which in that row it contains total underscore rooms minus total underscore bedrooms, and apply it, across rows. So, and that's why x is equal to 1. Okay. So the moment I apply it, it gives me the result, the difference. Okay. I could have done it in a different way as well, but the point is that if you know to apply lambda function, it becomes easier to kind of use it for multiple purposes. So what other that I could have done is California, and so total, and it's a very much simpler way, but uh, just for your knowledge, total bedrooms, and if you see, right, 4329, 5749, and so basically you can deduct one series from another series that you can do. So it's basically deduct one column from another column, so it will work across rows. Okay. And then now let's go down to concatenation, which I wanted to cover today. And so concatenation, so basically there are two types of join, high level types of the way that we merge data sets. So there are frequently scenarios where, and in fact the most used is the merge one, where we basically, I have table 1, I have table 2, I need to do inner join. I hope you have background in SQL, so there is inner join, there is a cross join, there is a left outer join, right outer join, and the full outer join, right? So when we start looking into the linkages between the data sets, then there, or convert a normalized format to denormalized format, and that's where we kind of use merge. But here concat, what concat is used, it's more like, think of the scenario. Let me show you what is the scene here. So df1, if I draw it, okay, so this is like this, okay, and then df2, so now df1 and df2, it might be that this data site chunk has come today, and this data chunk has come yesterday, and now this has come today. Now you want to append it to the same table. Think of in the structured database, RDBMS, right? So now you want it together, bind it together vertically, and that's where concat is used. So data frame 1, data frame 2, put them in list and say pd.concat and ignore index. Sometimes that index might be the same, let's say this and this. So to avoid any kind of wrong joins on the index as well, just do ignore underscore index is true, so that you just want to stack. Okay, so that's where this concat is useful. So concat is handy. Sometimes even I tell you the scenario. Now you have a very big file. Let's say you have a .csv file and it is of 10 GB. Now you don't have this much size to memory size to where you can apply some functionality on a particular column, right? Now for a particular, now you want to do some functionality. Let's say you want to multiply, you want to do the square of a function in that column for a particular file, but that file is so big that you can't load it, and pandas, we are saying that pandas cannot help it here, but no, we can do it. Remember Zimi in the last lecture shared around the chunking mechanism in pandas, right? The moment you read CSV, you can read it in chunks, right? Now think of the scenario, and where you can one by one do the manipulations, okay, do the manipulation and read data frame, small data frame one by one, And what you can do, you can, in each individual data frame, you can read it by chunk, apply it, read it by chunk, apply it, and keep writing it to, a particular file, and keep writing and adding into a particular file, and then at least take these concat into picture, and join these, concat these, and write it down till the size whatever you have in memory, right? And then you will have fewer number of sharded CSVs on your database, which you can then later on access, right? Or maybe you want to join some of these, you can load it, join it, and write it, right? You can't join CSVs like this, but you can of course, but data frame just gives you load those CSVs individually, load into data frames, join those data frames, write back to CSV, right? So this is what we are doing. So it concatenated our both data frames here into one, right? And basically ignore the previous indexes. Have I not done this, then as you can see, it is retaining all those previous indexes, and sometimes you might want to retain the indexes as well. It's up to you, use case to use case basis. Now you have data frames like this, and let's see what all data frames that I have. I've just created an example, sample example. Now df1 contains letter and number 1, right? And df2 contains a data frame, which df2 is a data frame which contains a letter as column, which is similar column, but there is another matrix attached to it. Now I want to see letter number 1 and number 2 in one data frame. Of course, this cannot be done by concat here, but what I want, that now letter A and letter B has number 1 and 2, and I want a data frame, like this. So basically letter A, B, D, the letters are A, B, and D uniquely, and I have correspondingly number 1 and number 2. If number 1 is available, it will be there. It is not available, it will be NaN. And it's just exactly similar scenario where what we do in RDBMS is, right? So data frame gives us very nice out of the box dot merge. So data frame 1 dot merge data frame 2, where left on means the key on which the left table is merged, is data frame is merged, letter, right? So left one is the df1, so df1 contains letter, and right on letter. So it might have happened that letter here in each of one of these has been different name, but you want to combine it. But these are the same, it just they are named differently. So it might have been letter X, letter Y, but you know that okay, these are same, and so you would have written here left on letter X, right on letter Y. And how need to join? Outer, inner, how? So outer brings in all the rows combinations, and that's why we are mentioning it as outer. Even we can also pass in right suffix and left suffix, which says that okay, if this same column has come from, there are common columns around and this is not in the join key, you can always say that okay, this common column has come from table X, and this column has come from table Y, right? There are scenarios. So okay, anyways, just to use it in a simple way, so if it is inner, let's say use inner. See, so only scenarios where it is matching is the letter A. So it will only take this row and this row, and number 1 and number 3 to show, right? Okay, so we're running short of time, and let me cover up quickly the group by thing. I haven't detailed out much in group by, but the command that I have written in group by literally works essentially for majority of the scenarios that you'll get, because I have written it in a generic way. I prepared. So this is not the generic way. So this is just to tell you So think of it that probably you have cities, and there are rows that you have another column, let's say date wise you have population, okay, of a city. So then there will be multiple rows for a particular city, right? And you want to see or you want to say and you might have a data set where date you have year wise in a city how many number of birth have happened, right? So now you want to sum up the total births happened in the last 10 years, let's say. And what will you do across cities? So now you want to say that, okay, city wise you want to understand what is the number of births that have happened. So what you will do in that case, cities dot group by name dot sum. Okay, so the date will be aggregated, and the output would look like this. This like your then grouping mechanism would be at name, and date would go inside in the aggregation, and you just sum up on a particular column. Let's say here is the population, and so whatever numerical columns it will get, if I don't specify, it will try to sum up all the columns. Okay, now the most generic way to write it is specify your list on which you want to group by. You can also provide a list here instead of this. Okay, probably like this, and so it will group by on multiple things, but ensure that whatever is in group by cannot be in aggregation. Okay, so now in aggregation you say that, okay, you know apply summation and average on population as a measure and create a measure, and this apply prod functionality, prod measure like sum here on new columns. You don't want to apply the same function to all of the measures. You want to do selectively, so you can prepare this JSON, and this becomes your ETL process, kind of more generic ETL process, help you write a general ETL process. You just specify your functionalities and pass that JSON config to this, and it will do it for you. See, by city it will give you, for on population it will give you sum, mean, and on new column it will give you prod, because here it's just one row for one scenario, and that's why it is not showing. You are able to see that exactly it is this answer is same across it. But think of it will, and I think in the next lecture I'll ensure that this will take a data set and will show that this example how it will make useful, become useful. I would say just go back and try it out and let us know, and put comments in meetup.com, so wherever you find issues. Okay, and yeah, so this is it. Next time, the time series, how to handle time series data in Pandas is something, because it's altogether a complete different effort to kind of spend time on it and thought process. So it will be covered next time. And just to summarize back again what we did today, overall, we covered the most common functionalities that are used, whether it's about describing or whether it's about dot columns, reading the file, okay, matplotlib inline, so that my all the plots are plotted inside the cells, and dot head, how many number of the number of rows that I give, accordingly it will print those number of rows. And I can even plot multiple measures here, as you can see here, multiple measures, and I can transpose, I can apply filter condition, I can apply isn't condition, I can apply lower casing conditions and filter my data. I can apply dot filter, which is for filtering out the columns by their names, and I can apply lambda function to filter my data. I can also apply regex to filter the columns out of so many columns. Generally it happens at the features level when you have lot many features, right? And you can also apply, you can update the column like dot loc and update particular column based on the range of the number of rows index, right? And also you can check how many nulls are there in your data set, so to save you time. And also you can treat your outliers by this condition, as we did here. We first introduced nulls just to simulate the problem of having nulls, and then we applied, imputed with the mean. But there are other much more better ways as well. But these are the basics, that okay, if you have mean value, at least you can impute that. And then so this scenario will be covered later. And yeah, okay, so remember we did the lambda apply function for calculating the other rooms apart from total bedrooms at a particular location, and we did in multiple ways, like directly deducting the column 1 from column 2. And then we did concat, stacked one data frame over another with and without index. And then we used merge to kind of merge the data set, inner, outer, join, and so on. And then we did group by, and we walked through this small example but more generic way of writing the group by in Pandas. Okay, yeah, so that's for all for today. And is great. Thanks for your time, first of all. Thanks for your time. Sunday morning, coming every day and interacting with us and looking through the videos, and we'll always be happy to help in case of issues. And we are just I know that we are just lagging on some infrastructure related, logistics related issues. Sometimes internet gets broken in between, sometimes you know but we are working out on those ways what we can do. But at least we want to make it a continued success, and whatever help that we can provide to you. And we just want that this first series to be run, as this is acting as an experimental series. In the next series we'll again restart this series once this one complete end-to-end journey is done. Then we'll again restart in a much more better way, and much more scalable way. But for now, because we have to manage all this, so we are doing it like this. Thank you, and goodbye.